Alrighty. Hello, Professor, or whoever is watching this. It's me, Zach, here, and I'm going to be doing our final presentation here for the PKI Classroom Scheduler. Um, so, to get started, I just want to say thank you for a wonderful semester. It was very enjoyable, and it was a really fun project, and I'm glad that UNO was our client. It was fun. It was an interesting problem, and I'm really proud of all the work that we did this semester. Alright, let's get started. Okay, so here's just a brief presentation outline. I'm going to start with a system overview, then move into the under the hood / architecture discussion, then move to how we developed the app, then the CS problems that we tackled, and then finally the local and global impacts that our application is going to have. So getting started here with the system overview, what exactly does the UNO Classroom Scheduler do? Well, in a brief description here, it allows the department heads to more easily schedule classes each semester by allowing them to use a web app connected with a database, so scheduling data is consistent across all machines instead of manually editing a CSV file and passing it to other department heads physically / through email. So essentially, the problem our app is solving is allowing all of the department heads to concurrently work on the same CSV file, the same schedule, without having to pass a CSV file back and forth to check for conflicts, see what's still open, so on and so forth. Instead, they're able to just go onto the website once it's deployed and just do everything from there, and then once everything is said and done and everything is finished, then they could just download the CSV and send it through CourseLeaf. And that sort of leads into the second point here. Why did we make this app? So scheduling is really tedious and it can take months to complete. Scheduling for upcoming semesters starts as soon as the current semester starts in order to finish it by the time that everybody can start signing up for things, or that's the goal, is to be able to have scheduling finished before students can start signing up for classes. So it involves a lot of people working on the same document, the same CSV file, and passing it back and forth until something that everyone's happy with is created. And so by creating this application, we can really shorten down the time needed to write a schedule from months down to weeks, or maybe even days, if the department head just wanted to sit down and do it all at the same time. So when will this app be used? So this application could be used every semester. Whenever scheduling has to happen, all that the department heads have to do is grab the CSV file from the previous semester, upload it to the application, and then make the changes that they need, and then download the new one. So it allows them to use it when they need it. Now, of course, by lowering the amount of time that's needed to make the schedule, that means that they're not going to have to use the app as often, because it only takes a week for them to make the next schedule, which is the goal. And then next point, who's using it? So this app is going to be used at UNO specifically by the department heads of the College of IS&T. So that would include the head of computer science, the head of cybersecurity, so on and so forth. And they are in charge of making the College of IS&T's semester schedule every single semester. And what can users do on the app? So users are able to search for classes, they're able to search a room number, see what classes are taking place in that room, what time it's happening, what day it's happening, or they can search up a professor's name and see what classes those professors are teaching, when they're teaching it, what day it's happening on, and what room they're in. So that way, they have a few different views to see, what's going on. So let's say a professor wants to schedule something in a computer lab. They can look up the computer lab room in here and see what classes are already happening. So they can say, hey, great, that I can see that, let's say room 155 was a computer lab. I can see at 1:30, which is 13:30 in 24-hour time. That's what our application is using, is 24-hour time. On Tuesday, there's an opening from 1:30 to 15:30. whatever it is. And so they could schedule their lab for that time in the computer lab. Or, if they want a specific professor to teach a specific class at a certain time, they could look up the professor's name instead and see what times they have available to teach. And then other than just searching classes, you're able to add a new class or instructor that wasn't in the schedule previously. So when you upload the CSV, all of the classes that were in that CSV are automatically parsed and added to our database. So we can see, hey, Principles of Programming Languages existed last semester, and it was taught by Gregory Gelfand. But that means if a new class is being introduced or a new professor starts working here, we need to have the capability to add a new class or a new instructor to the schedule, and so we added that functionality. Then users can also edit or remove existing classes from the schedule. So by simply clicking on a class, you're able to change what time it's happening at, or what days it's happening on. We hadn't gotten it to work to change rooms at this point in time, but that was something that we are wanting to do. Or you can also just remove a class. So the idea is that if you wanted to move a class to a different room, you could just remove the class overall and then go add it into a different room that way. So that's one way that you can do it. And then users can also learn about us, the creators. So here's a brief logical decomposition. So it's pretty, high level here. There's not a lot to go into, but essentially there's users, admins, data, and then analysis of the data. So users contribute to admin by adding schedules. So the user would be the department heads, and they're contributing into the administration of the application. Then admin contributes data by setting up the initial schedule, so the admin is essentially the first person to upload the CSV. So users contributing to admin by updating the schedule and doing what they're supposed to do. Analysis processes the changes and room assignments that requires the CSV data, and it contributes to admin by finishing the CSV and feeding it back to the admin via the download function. And then data contributes changes to analysis for new room assignment. So data is just the stuff that's being fed into analysis to change. Then for our tech stack, for our front end, we used Angular.js, which is a JavaScript framework that utilizes HTML, CSS, TypeScript, and JavaScript for components and things. And then we used Protractor, and Jasmine for testing. Protractor and Jasmine are a automated testing environment. Jasmine is essentially the web host for the automated tests. It's what opens the browser and gets things to run. And then Protractor is our tests case is written in TypeScript. And then for the backend, we used .NET and SQLite for our database. And .NET is a C# framework. And then here is our deployment view. It's also relatively basic. The idea behind it is here in the bottom right, the user is they have the front-facing HTML in their browser, which is going to our web server, which isn't currently running. We have no deployed web server, but on there would be our Angular front end and our .NET backend, where everything is happening, and that's connected through HTTPS through port 4200 when it's running locally. And then our web server would be connecting to our database server in order to save and retrieve data. And then here is a relatively high-level development view. Our tech lead was the one that created these, and he isn't here with me. So I will do the best that I can to narrate what's happening here. So the image on the right is essentially just an overview of essentially what the front end is doing. So we have our UI components, which is what the user is saying. It's the HTML that we are creating on Angular that's front facing for the user to see. Feature services, which are the services that are connecting it's what's sharing data between front end components. And then state management, which is going to be sort of like our forms and things like that, if I'm remembering correctly. And then HTTP data services are, I guess, sort of self-explanatory. It's supposed to just be built-in HTTP data services, I guess. Then on the left side here, this is supposed to be more of a back-end image. So we have our business logic that is making some sort of persistent call to the repository, and then the repository is retrieving data from the data source as queries are coming in from the business logic as well. So yeah. Moving on, how we developed it. So the tools that we used for IDEs for front end, we used VS Code pretty much exclusively, and then for the back end stuff, we used Visual Studio. We have all our code stored in GitHub repositories. We have two separate repositories, one for the front end project and one for the back end project. And then we used Jira as our issue tracker. And then we can see a pretty high level milestone breakdown here. For milestone 1, we figured out what we were going to do. We decided what technologies we wanted to use. We started designing our wireframes, and we started our setup after we figured out what languages we wanted. Then milestone 2, we had our project fully set up, and we began work on front end and back ends, and we had some basic components and things set up on the front end, and then the back end was getting started as well. Milestone 3, we had separately working front end and back ends with basic pages and functions. So essentially that just means that we had a lot of working things at that point, things that we could move forward and start to interface them together. Then milestone 4, we have the front end styled with working interfaces between the front end and back end. So that's sort of leading off of milestone 3. We had completed components on the front and back end, so we could start interfacing the two together and start making calls to the back end from the front end. And then milestone 5, complete front end interfacing with back end and reading and sending data to database. So after we created our services connecting the front end to the back end, we needed to actually get data to send and be received from the database, because that was one of the most important parts of the application. Then here's some CS problems that we tackled. So the first and probably one of the biggest ones was educational timetabling. So at the very beginning of the semester, Professor had sent us a journal on educational timetabling, and it really went in depth on algorithms and things that are used in educational timetabling, because it's a relatively large problem that doesn't really have any one true good solution, and so there's a lot of options that we had going into it on what we wanted to do. And that sort of leads into the second point here, algorithm design. We got to pick the algorithms that we wanted to use, that we thought were going to be the most efficient and what we thought would be the best for our needs. So Ethan was actually the one working on the algorithms, and he sort of settled on using a genetic algorithm and just having it sort through classes to get a 100% perfect fit if we were able to get the auto-filling working, which we weren't able to, unfortunately. The next problem was routing. So I myself did a lot of front-end work in our project here, and this was an issue that I had specifically dealt with. Angular is sort of weird when it comes to routing, so there's either a really easy way of doing it or a really hard way of doing it. If something is just being used for navigation, like a button or something like that, inside of the button you can just put a router link tag, and it's really easy, and you can just route it to whatever page you want to go to. But if a button is supposed to run something and then take you to a different page, that was a whole other problem, and we ended up actually not really figuring out how to do that, but we did, because when you add a class, after you add a class, it takes you to the success page, and it shows you, if something was a success or a failure, and why that was. And then our fourth issue here was CSV / language parsing or processing. So the CSV is really big. There's a lot of columns that contain, very specific data in a very specific format that had to be parsed and processed in very specific ways in order for it to work correctly. And then lastly, component communication. So like I briefly said when talking about routing, we had to figure out how to get data to pass between different front-end components, even though a call was happening when we were searching for a class or adding a class, but we wanted the data to be consistent and pass to our success component, our success page, and that was a task, as well as communication between front end and back end as well. And that seemed to actually be a bit easier than passing things to and from different front end components, just because Angular and .NET work so well together because they're both Microsoft products, so they were built in a way where it just worked. And then here are some local and global impacts. So the expected contributions that we think we can have right here at UNO is that it'll make scheduling faster, easier, and a much smaller headache than what it currently is for department heads. They don't need to scramble to change a schedule if another department head took the room or time that they were wanting for one of their classes. Then next, because this is now an open source project, any school or university could build off of what we've created to make their scheduling process faster and easier. We were told at the beginning that CourseLeaf is a relatively common software used at universities for scheduling, and so because this application was built with that specifically in mind, it's a lot easier to transfer. It's much more transferable to other universities. And then finally, this makes the world a better place for students, instructors, and faculty alike, as now there isn't a need for any, there won't need to be any confusion on who's teaching what class, where it's at, and when it'll be. So earlier, we had stated how this application, the goal is really to have a schedule built before students can start signing up for classes, because there's a really big problem where with the previous semester schedule getting reused, if a professor is quitting or gets fired, or if they decide not to teach some class, or it's getting moved to a different time, and students don't know that when they're signing up for it, they're expecting to be able to take this course, so they're not signing up for anything else. And because that happens, they get complacent and they think, hey, I'm good, this class is going to happen. But then maybe 2 or 3 weeks before the school year starts, we made a mistake, this class isn't actually happening anymore, you're all going to have to sign up for something else instead. And if something is required for graduation, then that's a really scary thing for students, because now it means that they might not graduate that semester, or it might extend their graduation timeline, and that's really stressful for everybody involved, students, instructors, faculty alike, because the instructors are the ones that are going to end up dealing with the brunt of the of the emails and things like that. I'm going to email the professor and say, hey, why isn't this class happening anymore? What's going on? And then advisors on the faculty side, they're going to get a lot of emails as well saying like, hey, I can't graduate now. What am I going to do? And it can really help a lot of people by getting a schedule out sooner. And that is all I have for you. Thank you so much for listening to me. And again, thank you for a great semester.